Welcome to Listen and Learn Code, the podcast where you learn about programming and tech topics without needing to watch a screen. This podcast is unique in its focus on explaining deep technical topics in a primarily audio format. I'm Michael, your host. In this series, we'll dive deep into Django. This podcast is designed to help you grasp the foundational and advanced aspects of Django, making it accessible wherever you are. So, what exactly are Django signals? Think of signals as messages or notifications that let different parts of your application know when something significant happens. For example, when a user signs up on your website, various actions need to happen automatically, like sending a welcome email or updating some records in your database. Instead of writing code in multiple places to handle these actions, Django signals allow you to centralize this logic. You simply define what should happen when a particular event occurs, and the signal takes care of notifying the relevant parts of your application. To make this concept clearer, let's use a real-world analogy. Imagine you're in a large company where different departments work together to complete projects. When a sales department closes a big deal, it's essential to notify the finance team to start invoicing, the product team to prepare the product, and the customer support team to be ready for any questions from the client. Instead of having each department constantly checking in with sales, the sales team sends out a single notification like a company-wide email that tells everyone the deal is closed. Each department then acts on that notification in their own way. In this analogy, the company-wide email is the signal, and the actions taken by each department are like the responses from different parts of your application. Now, let's talk about the design pattern that Django signals follow. Django signals are an implementation of the observer design pattern. The observer pattern is a common design pattern in software development, where an object, known as the subject, keeps track of a list of dependents, called observers, and notifies them of any state changes. In the context of Django signals, the signal itself acts as the subject. When a particular event occurs in your application, like a user signing up, the signal sends out a notification to all the connected observers, which are functions or methods designed to respond to that event. These observers are often referred to as receivers in Django. Now let's think about how this design pattern works architecturally within your Django application. Imagine that your application is like a network of different components, each with its own responsibilities. Some components handle user management, others deal with emails, while others might manage your database. When an important event occurs, like a user signing up, instead of each component constantly checking for changes or events, the signal takes care of sending a notification to the relevant component. This architecture helps keep your application modular and efficient because each component only needs to focus on its own task without worrying about how or when it should react to other parts of the application. To give you a more concrete idea, picture a scenario where your application needs to perform several actions when a user registers, sending a welcome email, logging the registration, and maybe updating some statistics. Without signals, you would have to write code in multiple places, tightly coupling these actions with the user registration process. With signals, you can centralize this logic. This keeps your code cleaner and more organized, and it makes your application easier to extend in the future. Moreover, using Django signals aligns with the principle of loose coupling in software architecture. Loose coupling refers to reducing the interdependencies between different parts of your code. By using signals, the components in your application are loosely coupled, meaning they can operate independently and don't need to know the inner workings of each other. To sum it up, the architecture of Django signals is built around the observer design pattern. This design promotes loose coupling and modularity, making your application easier to manage, extend, and maintain over time. By using signals, you can separate different pieces of logic into their own functions or modules, instead of cluttering your views or models with a lot of extra code. This separation makes your code easier to read and manage, especially as your project grows. Additionally, signals are great for handling actions that need to occur across different parts of your application whenever a specific event happens. This could be anything from sending notifications when a user updates their profile to automatically adjusting inventory levels when an order is placed. However, it's important to note that signals are not always the best solution for every problem. They are most useful when you have loosely connected components that need to stay in sync without directly depending on each other. For example, in a blogging platform, you might want to automatically update a search index whenever a new blog post is published. Instead of tying this logic directly into the blog post creation process, you can use a signal to trigger the update. This way, your search functionality remains separate from your blog post logic, making your application more modular and easier to maintain. So, to sum up this part of our lesson, Django signals are a powerful tool for creating more dynamic and decoupled applications. They act as a messaging system that lets different parts of your application know when something important happens, allowing you to keep your code organized and efficient. Now, let's move forward and dive into some of the built-in signals that Django provides out of the box. These signals are designed to help you manage and react to common events that occur within your Django application. First, let's talk about the pre-save and post-save signals. These are some of the most commonly used signals in Django. The pre-save signal is sent just before a model instance is saved to the database, and the post-save signal is sent right after the instance has been saved. Think of it like this: when you're writing a document and about to hit the save button, pre-save is like a reminder that asks if everything is in order before you actually save the document. After you save it, post-save is the confirmation that everything has been stored properly. These signals are incredibly useful when you need to validate or modify data right before it's saved, or if you want to perform an action after the save, like sending a confirmation email or updating related records. Next, we have pre-delete and post-delete signals. Just like the save signals, these are triggered before and after a model instance is deleted. These signals are handy when you need to clean up related data or perform some logging before or after an item is deleted from the database. Another interesting signal is Ep002 changed, which stands for many to many changed. This signal is triggered whenever a change is made to a many-to-many relationship in Django. Many-to-many relationships occur when an instance of one model can be associated with multiple instances of another model, and vice versa. Think of it like a social media platform where users can follow multiple other users, and each user can be followed by many others. Whenever a user gains a new follower or loses one, the Ep002 change signal can be used to perform actions, such as updating a follow account or sending a notification. Moving on, we have request started and request finished. These signals are sent at the beginning and end of an HTTP request in Django. When a user visits your website, request started is triggered as soon as Django begins processing the request, and request finished is triggered when Django has completed handling it. You can think of these signals as bookends that allow you to perform tasks at the start or finish of handling a request, like logging the time it takes to process a request or cleaning up resources after the request is done. Finally, let's talk about the signals related to user authentication: user logged in, user logged out, and user login failed. These signals are triggered when a user successfully logs in, logs out, or fails to log in, respectively. They are useful for monitoring user activity, such as keeping track of login times, logging failed login attempts for security purposes, or sending users a notification when their account has been accessed. Now, let's look at some practical examples where these built-in signals might be useful. For instance, you could use the post-save signal to automatically send a welcome email to a new user right after they've signed up. Or, you could use the pre-delete signal to make sure that when a blog post is deleted, all of its related comments are also removed to keep your database clean. Another example could be using user logged in to log the time and location of each login, which can be useful for security audits or personalized user experiences. While built-in signals are powerful tools, it's important to use them wisely. You should rely on built-in signals for tasks that naturally occur in response to the specific events they are designed for. However, avoid using signals for critical functionality that should be handled directly within your application logic. Overusing signals can make your code harder to follow and debug, so it's best to use them for auxiliary tasks that enhance your application rather than tasks it depends on. To wrap up this part of our lesson, built-in Django signals like pre-save, post-save, pre-delete, and others are useful for responding to key events in your application's lifecycle. They allow you to keep your code organized and respond to changes without cluttering your core logic. In the next part, we'll explore how to create and use custom signals to handle even more specific events in your application. So far, we've explored the concept of signals and looked at some of the powerful built-in signals that Django provides. Now, let's move forward into more advanced territory by discussing how to create your own custom signals. This is an important step, especially when you're working on more complex applications that have specific needs beyond what Django's built-in signals can handle. First, let's talk about why you might need to create custom signals. As we've learned, built-in signals are great for common events, like saving or deleting a model instance, or tracking when a user logs in or out. But what happens when you have a unique event in your application that doesn't fit into these categories? For instance, imagine you're building an e-commerce platform and you want to notify various parts of your system when a user completes a purchase. This could include updating inventory, sending a receipt email, or triggering a recommendation engine to suggest related products. Since this event is specific to your application, built-in signals won't cover it. This is where custom signals come in. They allow you to define your own events and broadcast them across your application, so different components can react accordingly. So, how do you go about defining a custom signal? Imagine creating a custom signal as if you're setting up a new messaging system. You need to define what kind of message will be sent and what information it will carry. When you define a custom signal, you essentially create a new type of message that can be sent when a particular event occurs in your application. This message can carry different pieces of data, like which user completed the purchase, what items were bought, and any other relevant details. This data is then passed along with the signal so that any part of your application listening for this signal can use the information to perform its task. Once you've defined your custom signal, the next step is to connect it to receivers. Receivers are functions or methods that will be triggered when a signal is sent. To connect a receiver to your custom signal, you have a couple of options. One way is to use a decorator, which is a special piece of syntax that allows you to decorate a function with extra functionality, in this case, connecting it to the signal. The other way is to manually connect the receiver to the signal by specifying the signal and the function that should respond to it. Both methods achieve the same result, but decorators often make the code cleaner and easier to understand. Now that we understand the basics of creating and connecting custom signals, let's think about how this might look in practice. Imagine you've defined a signal for when a user completes a purchase. You then connect several receivers to the signal, one to update the inventory, another to send a confirmation email, and a third to log the transaction details. With signals, you can decouple these actions. The logic that triggers the purchase completion doesn't need to know about how the inventory is updated, how the email is sent, or how the logging works. Instead, it simply sends a signal saying a purchase has been completed. The different pieces of functionality, inventory update, email sending, logging are handled independently by their respective receivers, which listen for this signal. Creating custom signals can greatly enhance the flexibility and maintainability of your application. They allow you to keep your code clean and modular, and they make it easier to add new functionality without disrupting existing code. However, it's important to use them with care. Signals are best used for actions that naturally occur in response to an event, but aren't essential to the core logic of your application. Overusing signals, especially for critical functionality, can make your code harder to follow and debug. Now, let's move forward to understand how signals are actually sent and handled within your Django application. This is an important topic because sending signals and managing how they are received is where the real power of signals comes into play. Let's start with the process of sending signals. Sending a signal in Django is like making an announcement. Imagine you are in a room full of people and you have something important to say. When you speak, everyone in the room who is listening for this specific announcement will hear it and can then act on what you said. In your Django application, when a certain event occurs, like a user completing an order or a new record being created, you can send a signal to announce that this event has happened. Any part of your application that is set up to listen for this signal will pick it up and respond accordingly. This allows different parts of your application to stay in sync without being directly connected to each other. Practical scenarios where sending signals is beneficial are numerous. For instance, if you have an e-commerce site, you might want to send a signal when an order is placed. This signal can trigger several actions, updating the inventory, notifying the shipping department, sending a confirmation email to the customer, and so on. By sending a signal, you centralize this announcement in one place, and then different parts of your application can respond to it as needed. Now that we understand sending signals, let's talk about the other side of the equation, signal receivers. Receivers are like the people in the room who hear your announcement and then do something based on it. In Django, receivers are functions or methods that you write to respond when a signal is sent. These functions are connected to specific signals and get triggered whenever the signal is dispatched. Registering a receiver function is like telling someone in advance, whenever you hear this announcement, here's what I want you to do. One important concept when working with receivers is a sender argument. This is like telling the listener not only to listen for a specific announcement, but also to pay attention to who is making the announcement. In some cases, you might want your receiver to respond only when a signal comes from a particular part of your application. For example, you might have multiple models in your Django app, and you only want to trigger a certain function when a signal comes from one specific model. The sender argument allows you to filter signals based on their origin, ensuring that your receivers only react to relevant signals. Let's also discuss signal dispatchers, which are at the heart of how signals work in Django. The dispatcher is like the person who makes sure that everyone who needs to hear the announcement does so. When a signal is sent, the dispatcher takes that signal and sends it out to all the connected receivers. The dispatcher ensures that all registered receivers get the signal and can perform their tasks. When dealing with multiple receivers, it's important to manage their execution order. Imagine you have several receivers connected to the same signal. The order in which these receivers are executed can sometimes matter. For example, you might need to update a database record before sending out a notification email. Django allows you to control the order in which receivers are executed by specifying their priority when you connect them to the signal. This way, you can ensure that your application logic runs in the correct sequence, avoiding potential issues that could arise from receivers being triggered in the wrong order. Now, let's take a step further and talk about some advanced techniques that can help you use signals more effectively in your Django projects. These techniques are important when you start working on larger applications where signals play a critical role. First, let's discuss the issue of signal duplication. Sometimes, in complex applications, you might encounter situations where a signal is sent more than once unintentionally. This can happen due to various reasons, like saving a model multiple times in a row or having multiple parts of your code trigger the same signal. When a signal is sent multiple times, it can lead to unintended consequences, such as performing an action repeatedly when it should only happen once. For example, if a signal triggers an email to be sent, and that signal is sent twice, the user might receive two identical emails, which is obviously not desirable. To prevent this from happening, there are techniques you can use to ensure that signals are only sent once. One approach is to use flags or status checks within your application. Before sending a signal, you can check if the condition that triggers the signal has already been handled. If it has, you skip sending the signal again. Another approach is to carefully manage the points in your code where signals are sent, making sure that each signal is triggered at the right time and under the right circumstances. This helps you avoid situations where multiple signals are unintentionally fired for the same event. Next, let's talk about controlling the order in which signal receivers are called. In complex applications, you might have multiple receivers connected to the same signal, and the order in which these receivers are executed can be crucial. For example, if one receiver updates a record in the database and another sends an email, you might want to ensure that the database update happens before the email is sent. This way, the email reflects the most up-to-date information. To manage this, Django allows you to control the execution order of signal receivers. You can specify the priority of each receiver when you connect it to the signal. By doing this, you can ensure that certain receivers are called before others, allowing you to manage complex signal chains effectively. This is particularly useful when your application logic depends on certain tasks being completed before others. Finally, let's explore the concept of weak references and their importance in signal handling. When you connect a receiver to a signal, Django uses something called a weak reference by default. A weak reference is a way of referring to an object without preventing it from being garbage collected when it's no longer needed. This is important because it helps prevent memory leaks in your application. If Django used strong references, the receivers would stay in memory as long as the signal exists, even if they are no longer in use, which could lead to unnecessary memory consumption. Using weak references ensures that your application cleans up unused receivers automatically. When a receiver is no longer needed, and there are no strong references to it, it is removed from memory, freeing up resources. This is crucial for long-running applications or those that handle a lot of signals and receivers, as it helps maintain optimal performance and avoid memory issues. To wrap up this part of our lesson, advanced signal usage involves preventing signal duplication, managing the order in which receivers are called, and understanding the role of weak references in preventing memory leaks. Now, let's take a step back and talk about best practices and some common pitfalls you should avoid when working with signals in your Django projects. Understanding these will help you use signals more effectively and avoid potential issues that could make your code harder to maintain. First, let's discuss when to use signals. Signals are a powerful tool, but like any tool, they're best suited for certain scenarios. One of the key strengths of signals is their ability to decouple different parts of your application. This means you can have one part of your app send a signal, and other parts can respond to that signal without needing to know anything about each other. This is particularly useful when you want to perform actions in response to events that occur across different parts of your application. For example, if a user updates their profile, you might want to log that change, send a confirmation email, and update some statistics, all without having these actions tightly coupled to the profile update process itself. However, it's important to recognize when other approaches might be more appropriate. Signals are great for decoupling and handling cross-cutting concerns, but they shouldn't be used for everything. For instance, if the logic you're trying to implement is central to your application's core functionality, it's often better to handle it directly in your views or models rather than through signals. Overusing signals can make your code harder to follow, as it becomes less clear where certain actions are being triggered. This can lead to maintenance challenges down the road, especially as your project grows and more signals are added. Now let's talk about some common mistakes or anti-patterns in signal usage. One of the most frequent mistakes, as we already discussed, is over-relying on signals for essential logic. Signals should enhance your application, not control its main flow. If your application depends heavily on signals for key functionality, it can become difficult to debug and maintain, as the flow of control becomes less predictable. Another common mistake is creating too many signals or receivers, which can lead to performance issues and make your application harder to manage. It's important to keep your signal usage focused and only use them when they add real value. To ensure maintainable and scalable signal implementations, always document your signals and the reasons why they are used. This helps other developers, or even your future self, understand the purpose of each signal and how it fits into the larger application. Django signals are a powerful tool in your development toolkit, offering flexibility and the ability to keep your application components loosely coupled. They play an important role in the Django ecosystem, allowing you to build more modular and maintainable applications. Thanks for tuning in to Listen and Learn Code. I hope you found today's episode on Django insightful and that it helped you deepen your understanding of this powerful framework. If you enjoyed the episode, be sure to subscribe so you don't miss any future topics. And if you have any questions or topics you'd like us to cover, feel free to reach out. I'm Michael, and until next time, keep learning, keep coding, and stay curious.